Perfect. All right, folks. So again, my name is Neka Sunlin. I am the Slow the Flow manager here at Resource Central. I've been with the program for about 8 years. And in that time, I have been to a lot of houses across the Front Range and seen a lot of sprinkler systems. And it never ceases to amaze me the different things that I see. So there are some similarities, but every sprinkler system is different. But we're going to talk tonight about some things that we're all likely to encounter when we're dealing with either our own or someone else's sprinkler system. All right. So number one, our goal for this webinar and our program in general is to save water. So along the Front Range, we use over half of our water outside for residential purposes. And most of that water that we use outside is going onto our turf grass. So we are going to talk a little bit about drip irrigation tonight, but we're really going to focus on the turf areas because that's where so much of our water ends up going. Okay. And hopefully at the end of this, you will just have a better understanding and means to get the most out of your sprinkler system. Okay. So a lot of the stuff that we're talking about tonight is going to be things you can do yourself for no money at all or for very low cost. And a lot of it is very simple to do. And making small changes can really make a difference in your water use. So it can save you potentially hundreds or even thousands of gallons a month during the irrigation season. Okay. And even if you don't significantly decrease your water use with these changes, they will definitely help you get more bang for your buck out of your water because you will have less water waste. So that's what we're going to do tonight. Okay. So here's just a preview of some of the things we're going to talk about. So we are going to talk about the main factors that contribute to the performance of your sprinkler system. We're going to go over some basic components and terms. Basically, you need to understand how to speak the language. Speak sprinkler. So we'll talk a little bit about that. We're going to talk about operating your system and maintaining it. How to schedule your watering, very important. And then at the end, we'll talk just a little bit about some upgrades and conversions that you can do to make your system more efficient and save more water. All right, so let's talk about the things that affect how well your sprinklers work. And by that, I mean, how efficient are they? Are you using the minimum amount of water and getting the maximum benefit? So let's talk a little bit about that. So there are really 3 main things that affect the efficiency of your sprinkler system and how well your sprinklers apply water to your landscape. Number 1 is the design, which is the layout of the system. So when it was built, which most of us inherited the sprinkler system when we bought the house, most people haven't put in their own sprinkler system. So you have what you have, okay? So it's the layout, it's the types of heads you have, okay? It is by far the hardest and most expensive aspect to change. So we're not gonna really focus on design tonight, just because, again, it's the hardest and most expensive, and we are trying to meet people where they are and help you use what you have as efficiently as possible, okay? But just understand that is an important aspect, right? The second thing is the maintenance or the condition of the system. So are things broken? Are things well adjusted? That's what we're talking about with condition, okay? And changing that, maintaining your system some things are very easy, some things are more challenging, and it can be free or it can cost a little bit of money. So the maintenance kind of has a wide range of the difficulty and the cost, okay? And the third thing that affects your sprinkler efficiency is the scheduling. So how often are you watering? How much water are you applying? And the wonderful thing about scheduling is it's easy and free to change it yourself. Okay. And we're going to talk in detail about how to program your control clock later on in the presentation. All right. So let's learn how to speak sprinkler. Okay. All right. So first here we have kind of the anatomy of a sprinkler system. So imagine you have X-ray vision and you can see underground, okay? So your water, and hopefully you guys can see my cursor here, comes in from the city line, this supply point of connection down here near the bottom, okay? Then you have a line that runs up to your house. And from there, typically the water line will split to go inside your house and provide water in your bathrooms and kitchen and everything. And then it will split off to a separate line that goes to the sprinkler system. That line to the sprinkler system here in blue goes through what's known as a backflow preventer, which we are specifically going to talk about. Then that goes to the valves. The valves talk to the sprinkler control clock, which in this diagram is here on the side of the house. It's usually in your garage or in your basement. The other side of the valves, there are what are called lateral lines. So that's typically PVC pipe that's underground. And those run out to various parts of your yard. And those are what connect the individual sprinkler heads to each other. All right. So we're going to talk about all of those components here briefly. But that is the general layout of a sprinkler system. All right, so let's talk about that backflow preventer. So if you've ever wondered what the heck is that funny looking thing on the side of my house, it very likely is your backflow preventer. Okay, so the whole purpose of it is to do what the name implies. It is to prevent water that is in these sprinkler pipes from going backwards into the water supply. The reason for that is certainly if you use fertilizer, put any chemicals on your yard, that those can get into the sprinkler system. And if that water flushes backwards out, then that can get into the water supply. And we don't want that to happen. So the backflow preventer stops that from happening. In regards to what you need to do with it, you typically don't need to interact with it very often, except for winterizing your system at the end of the irrigation season, and then when you turn your system back on in late spring. Okay, some people do this themselves, some people hire folks out to do it. We're not going to go into detail about winterizing your system in this presentation, but if you have a system, you likely have done it or had it done. Okay, but just so you know, this is typically where this happens. This does, again, supply water to the sprinkler system, and this is the place that you blow out your system in the winter. All right, so after the backflow preventer, the water flows to the sprinkler valves, which are located in a valve box. So again, if you've seen some funny looking green cover on the side of your house, that's likely what that is. They are usually right next to the house. They can be out in the yard, and you may have one or more of them depending on how many sprinkler valves that you have. And we'll talk about that on the next slide. Okay. This is what it looks like inside the valve box. So this is where the valves are located. So this box is basically an open bottom tub that is in the ground, and its sole purpose is just to protect and house those sprinkler valves. Okay, so the sprinkler valves are incredibly important. So they are basically the heart of the sprinkler system because they control the flow of water to the sprinkler zones and the sprinkler heads. Okay, so one valve equals one sprinkler zone. Another word for zone is station. We will talk about those here briefly. So you can see in this picture on the left, there are 4 valves in this valve box. So that means there are 4 corresponding sprinkler zones that go along with this. You can see the PVC pipe that supplies the water to each of those. And then the water goes out the top here to the individual zones. And if you're wondering why there are electrical wires in there, that is how the control clock communicates to the individual valves. The control clock sends a signal to the valve to tell it to open or close to supply water to that particular zone. And as I mentioned, you might have one valve per valve box, or you might have several. And again, you could have several valve boxes then across your property. All right, so I just mentioned the electrical wires going to the valves. The other end of those wires is your sprinkler control clock. That's the brain of the system. So the valves are the heart, the control clock or controller is the brain. So I have pictures of 3 of the more common ones here. There are dozens, if not hundreds, of types of control clocks. It never ceases to amaze me how many of them there are. And they all do the same thing. They turn the sprinklers on and off on a set schedule at designated times. So it's a little bit of reinventing the wheel, in my opinion, of how many of these there are. Some of them are very fancy, so they can have different features. but they all have the same basic features to do that. And it's just, again, to turn your sprinklers on and off at set times. All right, so zones. So it's very important to understand what a zone is, which is why I have this slide back up here, or a similar one. So you can see here, there's a red valve one that says it's open, and you can see the flow of water going out here via the lateral lines, so those pipes that are under the ground, out to the sprinkler heads. So there will be a series of sprinkler heads that are all plumbed together that way. So that underground lateral line piping will connect any number of heads. It might be 2 heads, it might be on a large property at an HOA, it might be 100 heads. Usually at most houses, it's gonna be anywhere from 3 to 10 heads on most zones, I would say. I have seen fewer, I have seen more. So you can see also in this diagram, there are two other visible zones. So you have zone 2, valve closed, that comes out here to the front yard. You can see how those heads are plumbed together. And then there's a third zone on the side of the house you can see. So again, just important to understand what that is. And the whole reason that there are zones and not every sprinkler comes on at the same time is mainly due to pressure. There wouldn't be enough water pressure to supply all of those heads on your property with water at the same time. So that's why it's done in areas. So very important to understand what zones are, because all of your scheduling has to do with zones. All right, so next let's talk about heads and nozzles. So it's very important to understand the distinction and the relationship between the two of these. So your heads are primarily underground, so you only really see them whenever they are running. Most of the time you don't see them at all. So this is actually a cutout. Again, we have X-ray vision, we can see underground. You can see ground level here, you have the dirt and the grass. You can see that the head is completely underground, so you have the head housing. It's connected via a swing arm with funny pipe down here to the lateral line. So this lateral line you can see running left to right. That's going to other heads and then ultimately back to the valve. So what happens is when that valve opens and water floods the lateral line, it goes to the heads, and the water pressure actually forces the stem of the head to pop up, and that's what you see. Okay. Then when the zone shuts off, the valve closes and there's no more water pressure, there's actually a spring that pulls that back down into the ground. So that is your head. The nozzle is a component, or it goes inside the head. So the nozzle is a much smaller piece, and that is where the water actually comes out. So it's kind of the mouth of the sprinkler head. And those are interchangeable. So the reason I'm stressing kind of the importance of understanding the difference between the two is there have been many times I've heard people say, I'm not happy with how that head is spraying, so I need to replace the entire head. And often it's just that the nozzle needs to be replaced, which is much easier and cheaper to take care of. And we'll talk about that in a little bit. All right, so let's talk about the 2 basic categories of heads. And then there are variations on a theme, but you have 2 basic head types. So here on our left are rotor heads. So in a nutshell, rotors rotate. So there's a stream of water and there's a turret at the top of the stem of that head that goes back and forth in a set pattern that's called the arc, or the path of travel. Then on the right, we have a spray head, which is stationary. So it sprays a kind of, again, a set pattern that's an arc, but the head is not rotating. So those are the 2 basic distinctions between rotors and sprays. And it's important to understand the difference because they have different properties and characteristics. In general, your rotors have a lower precipitation rate, which is the rate at which they apply water. So you have to run them for longer than you run your spray heads. So it's important to understand the difference there. As you can see, the rotors are physically larger. So once you know the difference, it's actually very easy to identify if it's a spray head or a rotor head for the most part. All right, so within rotors, there's kind of two subcategories there. So there's the gear-driven rotor on the left, which we already saw, and then on the right, this is actually called an impact rotor. So it's still a rotor because it rotates. Most of us are familiar with these because they make that classic sprinkler sound. So that's what those are. Again, it's still considered a rotor because it does rotate back and forth. It's just another flavor of rotor, so to speak. All right, so now let's talk about nozzles. So here are some close-up pictures of the two heads working. So on the left, we have the gear-driven rotor. So this red part right here, where the water coming out is what coming out is the nozzle. So again, it's basically the mouth of the head. And then on the right for our impact rotor, this blue piece right here where the water's coming out is the nozzle for that. So you can change these nozzles out to adjust the spray pattern. You can have it come out at a lower angle, a higher angle, wider angle, narrow angle, things like that. So it's very straightforward to change. On the gear-driven rotors, if you can see this tiny screw here, that's called the set screw. It's also the radius reduction screw, which we're going to talk about later. You basically back that screw out, and then this nozzle will pop out. So this screw physically holds that nozzle in there. On the impact rotor, you don't even need a tool. There's not a great view of it here, but basically from the other side, you can basically rotate it and pop it out with your finger to replace those. So pretty straightforward to do. All right, so now let's talk about spray heads. So we basically have two subcategories here as well. So on our left, we have the picture we already saw. So this is a spray head with a standard nozzle. And on the right, we have the same type of head. It's still a spray head, but it has a different nozzle on it. This is a rotary nozzle. These are often commonly called high efficiency nozzles because they are intended to save water, be more efficient, in that they have those larger water droplets that are less prone to evaporation and loss due to wind. They have a much lower precipitation rate or application rate that they put the water down on the grass. So they help prevent runoff in that way. But on that note, it's very important to understand that these two types of nozzles have drastically different precipitation rates. It's usually on an order of about 3 or 4 times difference. So you need to water heads with the rotary nozzles 3 to 4 times longer than the ones with the standard nozzles just to apply the same amount of water. So this is actually something that we commonly see is folks will change out a regular standard spray nozzle for a rotary nozzle, and they do not adjust their run times at all. And then their grass turns really brown and they don't understand why. So if you do that, you need to triple or quadruple your run times. Also, if you do that, please do it to the entire sprinkler zone, not just the one head. Because if you change, say you have 4 heads in a zone and they all have standard nozzles, one of those breaks, you need to replace it, and you replace it with a rotary nozzle. That one head is going to put out 1/3 to 1/4 of the amount of water that the other ones are. So you're going to get very uneven watering. So when you change to rotary nozzles, it needs to be all or nothing for that zone. Now, it is completely fine to have one zone that has all standard nozzles in a different zone that has all rotary nozzles. Different zones can have different head types or different nozzle types, but within the same zone, you want to have the same head types and the same nozzle types to have the precipitation rates be as even as possible. All right, so here is a breakdown of the nozzles for your spray heads. So for the rotors, if you recall, especially for the gear driven, the nozzle was kind of inside of it in a hole, okay? These guys are right on the top on spray nozzles. So the visible part of the head below this yellow line, excuse me, is the stem, okay? Or the riser. You'll hear both of those terms used pretty much interchangeably, okay? You can see if you look real closely, you can see right here where that yellow line is, where the nozzle actually attaches to the stem. And it literally just screws on, righty-tighty, lefty-loosey. So if you can open a jar, you can remove and install a nozzle onto a spray head, okay? So over here for our standard nozzles, we have a couple different kinds. So there are ones that have a fixed arc. So again, arc is the piece of the pie, so to speak. So it's the shape of the spray that comes out. So usually those are indicated in degrees. So 90 degrees, 180 degrees, 45 degrees. So if you have a head that is at a corner of a rectangle, you're going to want a 90-degree nozzle. If it's a head that's along a sidewalk and it needs to do a half circle, that'll be a 180-degree nozzle. Okay. So some nozzles are fixed. So if it's a situation like I just described, you're probably fine just doing a fixed nozzle. And so every time it sprays, it's going to do that specific arc. If you have a corner or a shape that is not a perfect angle like that, it's kind of an odd angle, it's not quite 90 degrees, maybe it's 80 degrees, then you probably want to get what's called an adjustable arc or variable arc nozzle. And you can literally open and close that arc to custom fit it to the spot that it's in. So, and then that's one option. Also over here, before I forget, right next to this adjustable arc nozzle is a filter. So this filter goes down kind of inside the stem here. It rests just underneath the nozzle. And that is to do what it implies by the name, is it filters out debris so that the nozzle itself doesn't get damaged or clogged. And so if there's any dirt or anything like that in the water line that comes up through the head, that filter will catch it. And those do occasionally need to be cleaned. And we will talk about that in a later section. Now over here on the right, for our rotary or high efficiency nozzle, this is what one of those guys looks like. And again, you can see that junction at this yellow line between the stem and the nozzle. And then over here, that is what is the visible part you're seeing. And then down here, this is actually an integrated filter. So typically these the filter just attaches to the bottom of the nozzle. So it's one piece to pull in and out versus the two. But again, for the standard nozzles and for the rotary nozzles, it's literally righty-tighty, lefty-loosey to swap those out. Pretty straightforward stuff. All right, so here is a summary of our different head types, heads and nozzles. So over here on our left, we have our two main types of rotors. So our gear-driven and our impact. So again, those are just physically larger in size. They are intended for larger areas. And in some cases, there are some of them that are intended for very large areas like golf courses and things like that. And they do have a lower precipitation rate when compared to standard spray heads. So our spray heads over here on the right, we have our standard nozzle and our rotary or high efficiency nozzle. So the head itself is smaller in size than the rotors. Those are for smaller or more funky shaped areas, if it's not perfect angles, things like that. So keep in mind again that the standard nozzles have a higher precipitation rate. So they water faster. They're not better, they're not worse, they just water faster than the other head types and nozzle types. And then the rotary nozzles have a very low precipitation rate. And again, that's on purpose, okay? That's to help prevent runoff, which we'll probably talk about here a few more times, but you've all probably seen it if you've ever looked at your sidewalk after your sprinklers run and they're wet. That's usually due to one of two things, if not both. It's due to overspray, which we will talk about, or it's due to runoff. So most of us here have clay soil, and clay gets a bad rap because it is hard to dig in, but it's really good at holding on to water. But the issue is it won't absorb much water at one time. It saturates pretty quickly. And so you can't apply a whole lot of water to it at once, because what'll happen is it'll get saturated, and then any more water that you apply on top will literally run off. So if you have any kind of slope, it runs downhill. If it's flat, it'll just puddle and evaporate. So we don't like runoff. Okay. So those rotary nozzles were intended to apply water more slowly so that the soil can do a better job at keeping up with the sprinklers. So the result is, though, one head type and nozzle type per zone. So please don't pair rotors and sprays together, because again, it's a drastically different precipitation rate. You're automatically creating uneven watering. Same thing, don't use standard nozzles and rotary nozzles in the same zone for the same reason. Drastically different precipitation rates. So you're just creating uneven watering. And as far as a sprinkler system goes, the evenness of the watering is the most important factor. It's not how quickly your sprinklers water, because that we just accommodate by watering for longer or shorter times. We want them to water as evenly as possible, because we're trying to simulate rainfall, right? Think about rain. When it rains at your house, your front yard gets the same amount of water everywhere. So the east side of your yard gets the same amount of rain as the west side of your yard. That's what we're trying to simulate with sprinklers. They're not perfect, but we want to get as close to that as possible and water evenly. All right, let's talk a little bit about drip. So this is a great shot so you can see some of the main components of a drip line. So this big line running through the middle is our main drip line, and that's typically 1/2 inch or 3/4 inch poly tubing. And then offshoots of that, you can see this 1/4 inch, it's commonly called spaghetti line. And here, in this case, this is running individual emitters out to these plants, okay? So let's talk a little bit about different type of drip emitters. Advance my slide here, there it goes. Okay, so there are all kinds, and here are just some 4 general categories, but it really runs the gamut. And there's no right or wrong answer, because all of these are good for different applications in different instances, okay? So up here in the upper left, again, this is our main line, our poly tubing, and then this red guy right here, and then there's a black one right here. Those are individual emitters. These particular ones are commonly referred to as button emitters, because they kind of look like buttons. And those are generally rated in gallons per hour. So 1/2 gallon per hour, 1 gallon per hour, which means what the name implies. If you run it for an hour, you'll get a gallon of water. Like, they might be 2 gallons per hour, et cetera, et cetera. And then off of these button emitters, you can see this spaghetti line. So each one of these is going to a plant. Okay. And what's really neat about using those is you can have 2 plants with drastically different watering needs next to each other and watered off of the same zone, because if one of them needs twice as much water as the other one, you just put those different size emitters that feed those plants. So very easy to do there. Below that, we have another type of emitter. So this is called an inline line or inline emitters. So this is a small 1/4 inch tubing, and these teeny tiny holes right here that are about 6 inches apart, those are actually emitters that are inside the line. So it's integrated emitters in there, and they're at regular intervals. So typically it's going to be in 6-inch intervals or 12-inch intervals. And so those are really good if you have a pretty densely packed area with plants and they're regularly spaced. Like these are great for vegetable gardens or things like that, where you have plants at very regular intervals. And up here in the upper right, we have a soaker hose. So those just have literally thousands of teeny tiny holes where the water basically seeps out. Okay. Those are best generally for if you have like a shrub line, something like that. So it's densely packed. You don't have a whole bunch of individual plants, and that root system kind of covers the entire area. So it makes sense to water that entire general area, because that differs greatly from, like we talked about this first situation with the button emitters, where you're sending this spaghetti line to one very specific plant. So your plants can be several feet away and you're not watering the whole ground and wasting that water. So soaker hoses are great for, again, like shrub lines or places like where you're good watering an entire area. And then another type down here in the bottom right is a type of micro spray. So there are many, many, many types of micro sprays. This is just one. And these are effectively teeny tiny spray heads that we just saw that we would use on our grass. Excuse me. So those can be adjustable. You can get them in 360-degree sprays, things like that. Those are really good if you have a whole bunch of like perennials and it doesn't make sense to run individual spaghetti lines with emitters to all of those plants. Those can be very helpful. So they are not quite as efficient because, again, you're spraying that water over a large area that can, you can lose some water due to overspray and due to wind. But again, sometimes that's the best way to go if using the individual emitters doesn't work.
Hey, Neka, can I interrupt you for 1 second?
Yeah.
Can you please say the name again for the line with the integrated emitters for the veggie garden, just what it's called?
Yeah, so typically it's called inline drip irrigation. I mean, they're probably different brands have like their proprietary names, but it's inline drip line.
Thank you.
And also, if you Google drip line with integrated emitters, you'll probably find it that way too. Great question. Okay, so now another very important term to understand: hydrozones, not to be confused with sprinkler zone, although they are very important to use together. So basically, a hydrozone is an area with plants of a specific watering need. So here we have 3 distinct hydrozones in these pictures. So your turf grass is one hydrozone. It needs a specific amount of water. Your perennial garden is a completely different hydrozone. It needs to be watered a different amount at a different interval than your grass. And then you might have a vegetable garden that, again, has a completely different watering need and requirement. So all of those are different hydrozones. So most of us have multiple hydrozones in our yard. I personally have all 3 of these. I have grass, I have a perennial garden, and I have a vegetable garden. Okay, and they all get watered differently. So it's very important to understand that. And it's also very important to use the right type of irrigation for each hydrozone. So for all your turf grass, so your lawn, those spray heads and those rotor heads, that's literally what they were made for. So that's what you use them for. Your perennials and your vegetable gardens, pretty much anything that's not grass, you want to use some type of drip. It's just way more efficient. You can use spray heads. I have even seen people use rotors to water that. It's just not very efficient. And so I recommend converting that to drip if that's something that's reasonable for you to do. And we will talk about that at the end of the presentation. All right. So one thing that is very important to try and do is to have one hydrozone per sprinkler zone. So sometimes what we'll see is we'll see, say, 2 hydrozones in one sprinkler zone. So one sprinkler zone comes on and half of the zone is watering grass and half of the zone is watering a perennial garden. So from an ease of watering standpoint, that makes sense. But what will happen is, since those are 2 different hydrozones, the turf and the perennial shrubs need different amounts of water. You have to decide which one you want to cater to, because again, it's on one sprinkler zone, so that all gets watered at the same time. So in the case of turf grass and perennial garden, the turf grass needs way more water than your perennial garden does. So you've either got to severely underwater your grass and cater to the water needs of the shrubs, or you've got to severely overwater your perennial garden to cater to the turf grass. So it's much more efficient to have one hydrozone per sprinkler zone. Now, I know a lot of people, again, you inherited a sprinkler system. A lot of times when we do see kind of that split zone that way, it's because the entire zone at one point was grass, but then somebody converted part of the grass to a garden. And they didn't make any accommodation for the sprinkler system. So that's something that, again, we will talk about later when we talk about converting to drip, is how important it is to have one hydrozone per zone, and again, the same type of heads or same type of irrigation throughout the zone as well. All right, we are at our mid presentation question break. So Lisa, do we have any good questions? I'm sure we do.
We do, yes. Okay. So the first one is to kind of how to balance the needs when you have like a tree in the middle of your lawn.
Mm-hmm,
So obviously the sprinklers water the tree, but the
mm-hmm,
tree and the lawn have very different watering needs.
mm-hmm.
Particularly if someone cares more about the tree than the grass. So how do you kind of balance that since they're in the same zone?
So that's a great question. So there's a couple of things you can do. So if it is a very mature tree that has been there a long time, it has a very extensive root system. And so it's going to have a much larger water table to access than the grass does. So in that case, I would just cater to the grass, and then that tree is going to get water from that as well, but you're probably fine just watering to the grass. Okay. If it's a younger tree, or if it's a type of tree, hopefully it's not a cottonwood in the middle of your yard, but if it's a tree that needs more water, or you feel like the tree is not getting enough from what you're applying to the grass, then what you can do is still cater your sprinkler watering with your zone to the grass, and then just supplement that with water for the tree. Again, if you think the tree needs more, is what I would do. And not just, you can get out the hose, or a rainbow sprinkler, something like that. I would absolutely not overwater the grass to supply that to the tree. You can do it. It's just going to cost you a lot more money in water. So I would cater the sprinklers to the grass, supplement the tree if necessary. Great question.
Perfect, thank you. So next is talking about the high efficiency nozzles.
Mm-hmm.
Can we discuss a little bit more about what makes high efficiency efficient?
Yep.
And should people who have spray heads change to high efficiency, or does it depend?
Great questions. Yes, this is the great debate. So high efficiency, the reason they're typically called that is for a few reasons. So as I mentioned, they intentionally have a much lower precipitation rate, so they water slower. So in theory, you get less runoff from your soil because they will not saturate the soil nearly as quickly as standard nozzles will. So that's one way that they're more efficient, because you lose less water due to runoff. Another way is that they have much larger water droplets, and so you lose less water due to evaporation and wind. So those are the ways that they're considered more efficient. I personally don't think they're that much better. I have heard that, I can't confirm this, but I've heard in the lab, they're theoretically more efficient in those ways than standard spray nozzles, but in the real world, they haven't necessarily shown themselves to do that. So if you have them, I would keep them, but I would not necessarily go out and seek them out. If you have standard spray nozzles, so answering the second part of that question, it really depends. And I will say with the high efficiency ones, I have found them to be a little harder to customize to the shape of your yard. They actually have a tendency to have a greater radius. So radius is the distance they throw water. And their minimum radius, in my experience, is harder to basically fit it within your zone. So I have actually seen people that change from standard nozzles to high efficiency, and they create overspray for themselves, because the standard nozzles had a shorter throw distance, which was appropriate. And then they put on those high efficiency, which started throwing water further, and then they were throwing it onto their fence or onto the street. So if you have a fairly large spray zone, so the area that the heads are in is a fairly large yard, those high efficiency ones can be fine. It's just something you really need to take into account and do some measuring. Get out, a tape measure and see from a head to wherever it's up against the side of your house or your fence, whatever it borders, what that distance is, and then look at the specs on the manufacturer's website for the high efficiency nozzles that you're considering to see what their standard radius is, to get an idea, because they can be good in certain situations. So yes, it depends. Great question.
All right, thank you. And I think you're going over this later in the presentation. Are you going to talk about general time frame for when to turn your system on and off?
Yeah, so I'll just go ahead and mention that. I think that is literally here coming up soon. So I'll go ahead and mention it. Generally, you want to wait until it stops freezing. So you don't want to be using your sprinklers here in Colorado whenever it's still freezing at night, just because the water in the lateral lines underground will expand and you can actually burst your pipes. So you want to wait till it stops freezing in the spring. The general rule of thumb around here is Mother's Day, although it can vary. And at the other end of the season, turning them off, again, generally it's going to be around the first week in October, but it also really depends. So, great.
And we kind of had someone ask how to winterize. We're not going to go into that in great depth, but
Right.
basically the idea is you have air blown into your system to get all of the water out so that there's no water left in the pipes to freeze over the winter.
Correct.
Um,
Very important to do.
Yeah, some people can do it themselves if you feel confident in your ability to do that, or you can hire a landscaper basically to come out and do it for you. So,
Great.
okay.
All right, so I'm looking at time. I'm going to go ahead and move on because I know we have some important stuff coming up.
Okay. And just, we're getting a lot of drip related questions. People want to know a little bit about that. So if we have time at the end, we're going to go over all of those that people are asking in the chat.
Great.
Thanks.
Fantastic. Thank you. All right, so general operation maintenance. So how do we want to use and maintain our system? All right, so we just talked about turning on your system once it stops freezing. So again, rule of thumb is after Mother's Day, but check the weather where you live. Immediately, please do a visual inspection. So after your system is on, run each of the zones, go out and look at it. Look to see if anything broke or got maladjusted over the winter, and then make corrections as soon as you can. Another thing to do throughout the season is to mow regularly. I can't tell you how many houses I've been to where the sprinkler system's fine, but their grass is 6 to 8 inches tall. Your sprinklers can't work right. Your sprinklers generally pop up 3 to 4 inches. So if your grass is 6 inches tall, the grass physically gets in the way of the heads being able to apply water. So it's very important for your sprinkler system that you mow your grass. You want it to be around 3.5 inches tall max for your grass. All right, also throughout the watering season, please do regular visual inspections. So just like you did when you turned it on for the season, you want to go out and turn on each zone, walk around and look at the individual heads. Make sure nothing has broken. Make sure nothing needs to be adjusted. Okay, I suggest doing it at least once a month during the irrigation season, because you never know when something's going to break. Lawnmowers are notorious for taking out heads. If you have heads that are right along your driveway, people have a tendency to run over those a little bit, so those can break or get misadjusted. So doing those visuals regularly is important. Please also adjust your watering schedule throughout the season. We do not want to have a set it and forget it mindset. So you should not be watering the same amount at the beginning of June as you are at the beginning of August. You do need to adjust it throughout the season. And then we just touched on this a little bit. Winterize your system before it freezes. All right. Excuse me, I can't get my slide to advance. There we go. Okay, so we're going to quickly go over some of the most common things that you want to look for during your visual inspection and talk a little bit about how to address them. Okay, so here are a few things. All right, overspray. So here are 2 great examples of watering the street and watering our fence. So obviously, it's very easy to see here on this fence line where the water is hitting. no matter how much you water your fence or the street, it doesn't grow. And so this is just absolutely positively water waste, and it's one of the things we see at pretty much every house. Most people have at least a little bit of it. It can be challenging to completely eliminate it, but we definitely want to minimize it. And this, especially this example of the street, is pretty egregious. Okay. So how do we correct overspray? We're going to talk about that. You're going to do it by adjusting your heads. So this is something that most people can do themselves. It can be a little intimidating at first, but once you know how to do it, it's really easy. So it does depend a little bit on the brand, so the make and model of the head. The two examples I have on this slide are two of the more common brands, so Rainbird and Hunter. They're basically the Ford and Chevy of sprinklers. So most people have at least some of them, although again, there are other brands, and so the method of adjusting them is slightly different. So it's important to know what brand you have. You can YouTube how to adjust pretty much any head. It's usually pretty straightforward. So on the rotors here, you can adjust both the radius, so how far it throws. So if it's throwing too far and going into the street or hitting the fence, and you can also adjust the arc or that path of travel. So for the rotors, it's that path of travel left to right, okay? That might be the cause of the overspray if it's going too far one direction. So on both the Hunter and the Rainbird, you adjust the radius or the distance of throw right here. And you can't tell from this picture, but the nozzle is basically right here. And there's a screw here. This is that set screw. It goes down and physically holds the nozzle in, but it's also what controls the radius. So if you go clockwise and dial that screw down, you're actually pushing the screw into the path of the water. So it does make it not go as far. One thing to note about that is it does basically make it spray a little bit more sideways. So it does affect the character of the spray. So if you need to adjust the radius significantly, it's probably better to just get a different nozzle that has a different character itself. Okay. All right. And also, if you are trying to increase the radius and you're backing the screw out, be very careful, because if you back it out too far, then that set screw is no longer holding the nozzle in. And if you're doing this when the head is running, your nozzle will shoot out across your yard. So that can be fun. All right, for adjusting your arc and path of travel, there's another hole, and you can see it here on the Hunter, and then here, or here on the Rainbird, and here on the Hunter. So you do need a tool to stick down in there. The Rainbird, this is the green tool right here in the middle of the screen. It's basically a very small flathead screwdriver. So you use that to adjust your radius and your arc on here. The Hunter has its own special tool here, this white one. And this is a teeny tiny Allen head. I believe it's 1/32. It's a teeny tiny Allen wrench that you use to adjust the radius. And then you actually use the other end of that to adjust, you stick it down in this hole to adjust the arc. And again, you just play with it, you turn it one direction or other, and that will change your arc. So one thing to note about rotors is for the arc, one side of that path of travel will be a hard stop. It'll be fixed that you cannot adjust this way with a tool. So you'll just be adjusting one side. And the idea is that when the head was installed, that hard stop was lined up to the landscape to not overshoot. And so then you're just adjusting that other side. If your hard stop side is the side that needs to be adjusted, it really depends on the make and model of head, how you need to address that. Some of them you can actually turn the turret physically while it's not running to reset it. Other ones you have to basically disassemble the head and pull out that internal part and put it back down in. So that's, again, it's just important to know what head type you have, do a little research if you do need to adjust that hard stop side. All right, for your impact, it's actually much easier to change those. So here on the left, the radius adjustment, there's basically, usually it's plastic. There's a plastic screw here, again, that goes into the path of the water. So here's your blue nozzle right here, and you can actually see the hole where the water comes out of the nozzle. And you dial that screw, and again, it impedes the flow to shorten up the radius. And then for the arc or path of travel, there are actually two different They're like these little spring-loaded brackets. And you just slide them back and forth to impede this little tail coming down right here. And as this thing turns back and forth, that tail will hit those brackets and it shoots it back the other direction. You don't need any tools. You can do it with your hands. It's actually very easy to do. So those are more definitely more user-friendly when it comes to adjusting. All right, for spray heads. So a couple things you need to do to adjust the arc. So the first thing is the direction adjustment. So you want it pointing in the right direction first. And all these nozzles have a little notch or an alignment mark on one side that correspond to base. That's going to be your hard stop side. So similar to a rotor in that way. But these are much more easy to adjust that hard stop side. As in this first picture, you basically just grab that stem with your hand and you can turn it, ratchets. You can actually hear it and feel it click. It'll ratchet and you line up that hard stop side first. And then if it is an adjustable arc nozzle, there's typically a dial here and you can turn that and that will move that other side of that arc. If it is a fixed arc nozzle, you can't do that. And so if the arc is incorrect, the degree is incorrect, once it's lined up right, then that would be a case where you would want to swap out the nozzle for an appropriate arc. And then if you do need to adjust the radius or the distance of throw on a spray head, there's a teeny tiny screw on the top of the nozzle. So you just need an itty bitty flathead screwdriver. And again, righty tighty, lefty loosey, you can dial back or extend your radius. Again, though, if you need to change it significantly, you probably should just get a different nozzle. Generally, you don't want to change it more than 20–25%. Okay. All right. All right, clogged nozzles. So here's an example. Spray heads have a tendency to do this. So this picture on the left, you can see this spray pattern is all funky. You got one stream here and one stream here and nothing in the middle. So something's going on there. So the first step here would be to just see if the nozzle, or excuse me, the filter is clogged. So with the system off, you'll basically want to pull the stem up, remove the nozzle, just unscrew it, pull out the filter. And as you can see, this one is pretty icky. So very simple fix, just have a bucket of water there. If you know you're doing this, just put it in there, swish it around. You can take it to a hose or a faucet and rinse that out. Just get the gook out of the filter, put it back in, put your nozzle back on. One thing, if you do this, you do want to check your alignment after you do this, because it's very easy to accidentally ratchet that stem and redirect your pattern. So always check that your arc and your pattern are correct after you do something like this. All right, blocked heads. So here are two examples of the landscape probably used to look different. So here on the left, we have a rotor that is spraying right into some shrubs. And I can see some rotors going on the other side. So this is a case where probably originally there was grass here. And so this rotor was appropriate. And then part of this got converted to a shrubscape. And the head was not capped. This was not converted to drip, things like that. So what we have going on here is we have kind of an inappropriate head type for this area, but also if somebody is still intending this to water the grass on the other side of these shrubs, the shrubs are completely blocking the spray, so it's not going anywhere else. So that is an example of one type of blocked head. The other here on the right is something that we see a lot in people's yards, where something that is man-made or man-placed is now in the way of a sprinkler head. We see this a lot with things like trampolines, swing sets. So I'm not telling you not to have those things or even that you have to move them, but I've had people say, I don't understand why I have a brown spot now. And then we turn on their sprinkler system and we see something like this. So it's just an awareness more than anything else of you're not going to get as good of coverage from your sprinklers when you have stuff in your yard. And in the case of this one, this big landscaping rock. My guess is that was not there when the sprinkler system was installed. And then somebody put it there because it looks nice. And then probably didn't realize that that was going to impede a lot of the spray from this head. So again, I'm not telling you not to have stuff in your yard. I wouldn't move that rock because it's probably really hard to move. What I would probably do in this situation is I would adjust the arc coming out of this. So if this is an adjustable arc nozzle, I would probably have, instead of spraying about 180 degrees like it looks like it is, I would have it spray less than 90, because that's what it looks like it would just come on this side of the rock, because you don't need to spray the rock. If that is a fixed arc nozzle, you could swap it out for an adjustable one. So you still can use that head to water this grass that is not being blocked by the rock. So again, just something to be aware of. All right, so tilted and low heads. So pretty self-explanatory. So over here on the left, we have a tilted head. So that's pretty obviously tilted. So keep in mind, heads are intended to be perpendicular to the turf. If they're off by even more than 5 degrees, it does impact how well they're able to distribute the water where they're supposed to. So in this case, this example, this head is leaning into the turf, so it's not going to spray as far as what it's intended to. So you're going to get more brown spots a little further out from this head. If it's leaning back the other way, it's actually going to spray further and not spray the area closer to it as well. So this is something that happens in every yard as the ground settles. Okay. Also, it can happen if the head is run over by a lawnmower, a car, something like that. But even if that doesn't happen, everybody gets tilted heads because the ground settles, and that kind of shifts the head around. So the way to fix that is basically to dig it up. You have to remove the dirt immediately around the head, pull it up, reposition it upright, pack in dirt to get it back to completely upright. I typically do not recommend people do that until it's pretty severe, or if you're really unhappy with how the system is watering, just because it is a little more involved than just adjusting the arc and the radius like we just discussed. So just be aware of that ideally we want those to be straight up and down. And eventually, if you want to improve your coverage, you're going to have to straighten them. Very similar to low heads. So here, this is a rotor. You can't even see the head as it's watering, and you can clearly see how the water coming out is bouncing off the grass. And you can also see this kind of divot here in the grass. So as that thing rotates, here you get this kind of this overhead view. This is a classic sign right here of a low head, where it almost looks like a crop circle, where you have just this circle of laid down grass right around a head. So that can be either the grass is way too tall or it's a low head. And most of the time it's a low head. So similar to tilted heads, the way to kind of classically correct those is to dig them up, put more dirt under them, put them back to where the top of the head is at ground level. There are some other alternatives. You can actually loosen the dirt a little bit around the head, kind of remove it, add a riser to the bottom. That's another way that some people will do that. But ultimately, if you're not happy with your coverage, getting those low heads corrected is going to make a difference. There we go. All right, and then some of the more severe things. So broken heads or lines. So most of us can identify when something is broken because it has a tendency to be pretty obvious. So we'll go from left to right. So we've got a drip line here that got ruptured somehow. And those actually are pretty easy to rupture because that drip line typically is fairly close to the surface. A lot of times it's on top of the mulch or just under the mulch. We forget they're there. We use shovels, we use landscape stakes, and we'll accidentally puncture it. If it's a minor hole, you can just use what's called a goof plug to fix it. This is a pretty significant, this is probably a slice. So part of the line really should probably be replaced. But again, this is something that you could catch on your visual inspection. Next to that, we have what we call a geyser. So this is a pretty significant one. That head looks like it's completely busted. And in fact, it might be completely missing. I've seen heads basically blown off before. So that one is pretty darn clear that there's something going on there. This next example looks like more than likely it's not the head itself that has the issue. It's probably the lateral line. So that PVC that is feeding the head, because you can see the water coming up here at the sidewalk. So that one would take probably maybe a little bit of investigating to find out exactly where it is, and a bit more of an extensive repair than just replacing a head. We have another example that here on the right, where the head is probably fine. This leak coming up could be the lateral line, or it could just be the head is coming unscrewed from the lateral line because they just screw in. So that one may be a little more extensive of a repair, or it may simply be screwing the head back onto the lateral line. So a little more detective work there might be, easy to fix, might be a little more challenging. If you do find breaks like this, so this is obviously wasting a significant amount of water. So my suggestion is turn that zone off. So whatever you have that zone programmed to run, just turn that zone off. Put the runtime to 0 until you can get the repair made. All right. So scheduling. This is the stuff that's cheap and easy to do. Now, most people are quite intimidated by their control clock. That's okay. As I said, there's so many of them. That in itself is intimidating, but once you understand the basics, it's generally not that bad. So things to understand is that there are 3 main components to your watering schedule that have to be programmed into the clock to make it run. The first is watering days. So Monday, Wednesday, Friday, every other day. It can be different iterations, but you have to tell it what days to water. The run times is how long each zone runs. 10 minutes, 7 minutes, 52 minutes. That's your run times. And then your start times, which are your cycles. So start times are times of day. So what time of day are you telling your sprinklers to come on? 6 a.m., 10 p.m. Those are your start times. And you want to use the multiple start times, which pretty much every modern day clock has, to do multiple cycles, to do cycle and soak. So one cycle is 1 round of every zone running. So if you have 4 sprinkler zones programmed, they're going to go in order 1, 2, 3, 4. When they're all done, that's 1 cycle. So because we have that clay soil that I mentioned earlier, we want to do multiple cycles versus 1 long one. And I'll give an example of that in a couple of slides. So if you're planning on watering your zone for 30 minutes in a watering day, don't do it 1 time for 30 minutes. Do it 3 times for 10 minutes each, because that will allow that clay soil to absorb the water and you'll get less runoff. Okay. Another thing on your control clock to be aware of is multiple programs. So 1 program equals 1 schedule. So this is very important for watering your different hydrozones. So the example I'm going to give here in a couple slides is you have your turf zones on 1 program and on 1 schedule, and you have your drip line on another program on a completely different schedule. It's very handy. It's wonderful. Seasonal adjust is another feature that some clocks have, not all of them have it. And that is a quick and easy way to change the percentage of watering across an entire program. So if you decide to increase your watering by 10% and you want to change that across all of your zones, you can change that seasonal adjust by that percentage. And then another thing that some clocks have, not all of them, is a sensor toggle switch on this particular clock. It's this little green guy over here on the right. You see active and sensor bypass. So if you have a rain sensor, for example, hooked up to this, you want this to be on active so that the clock actually listens to the rain sensor. If you don't want it to listen to the sensor, you can flip it to bypass. But please don't do that. All right, so scheduling best practices. So please, 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 especially these days, check your water provider to see if you have any watering restrictions, because more and more of them are implementing that, and you can get fined if you don't water accordingly. So a lot of them will tell you you can only water certain days of the week. A lot of times they'll do it based on your address. So if you have an odd numbered address, it's these certain days of the week. If it's an even number, it's a different day. Or they may say, we don't care what days it is, but you can only water 2 days a week, or you can only water 3 days a week. So please make sure you know what your restrictions are if you have any. Also, a lot of them will implement timeframes. So most of them will say you cannot water between 10 a.m. and 6 p.m. Okay, so that's just good practice to avoid anyway, even if they don't restrict it, because it's not good to water during the day. So the good rule of thumb for when to water is when the sun is down. That's just a good rule of thumb, and we'll talk about that a little more. Also, we already talked about this. I like to beat this drum. Adjust your schedule throughout the season. So again, you should not be watering 3 days a week at the end of May. Okay. Just please make sure you're adjusting that based on the season and what the weather is. Don't ever water more than 3 days a week. For one thing, nowadays, there are a lot of water providers that will penalize you if you water more than 3 days a week. Plus, it's actually not good for your grass. Okay. So if you're watering 3 days a week and your grass isn't looking the way that you want, don't add another day. Water longer in those days if you need to do it. So that's the next thing on here is adjust the run times of individual zones. So if your backyard looks great and your front yard looks like it needs more water, just adjust the run times on the front yard. Leave the backyard alone. It's not an all or nothing thing. So really evaluate it on a zone by zone basis. And then again, another way to adjust is the seasonal adjust. That's my least favorite way personally to do it, just because it's across the board by a percentage. I prefer to, again, adjust the individual zones because typically not everything needs the same increase at the same time, but it is an available option on some clocks. And again, cycle and soak for those turf zones. So shorter multiple cycles versus one long one. All right, so how long to water? Everybody wants to know that. And the quick and dirty answer is it completely depends. It depends on the type of head you have. It depends on the type of landscape that you're watering. It depends on your precipitation rate. So it varies greatly. I always tell folks, if you and your neighbor are watering on the same schedule, one of you is overwatering or underwatering because every system is different. So I am providing some general ranges. Please keep in mind, these are extremely general and the ranges can vary quite a bit from this. So please take this with a grain of salt. So generally for spray zones, so those standard spray nozzles on spray heads, generally you want to shoot for 20 to 30 minutes per watering day. So at the beginning of the season, late May, when you turn your system on, you're probably just going to need to water 1 day a week. So 20 to 30 minutes per, then that's for each zone per day for that 1 day a week. Then as it gets hotter, you're going to add a second day. So you're still doing 20 to 30 minutes of watering day. You're just adding another watering day. That's how that works. For rotors, 30 to 60 minutes. So you have to water them longer because they have a lower precipitation rate. They put out less water over time. Rotary nozzles, 75 to 150 minutes per watering day. So it generally takes a couple hours, a lot of times, to water those zones that have those rotary nozzles. You're not using more water. It's just because they put it out more slowly, you have to water for longer. Again, these are general ranges. If you want to know how long specifically you need to water, you basically need to do some type of catch cup test to get your precipitation rate, which incidentally is something that Slow the Flow sprinkler evaluations do provide. We do the testing and we can provide you with a customized watering schedule based on the testing. You don't have to do that. You certainly don't have to have us come out. And if you don't want to or know how to do a catch cup test, because that can be a little complicated, just use these general ranges, okay? Start on the low end. So for sprays, start at 20 minutes. If you're already doing less than that and you like the way your grass looks, don't increase it. If you're happy with how your grass looks, don't ever increase your watering. But if you think it looks okay, or you think you're overwatering, start at the low end and see what happens, and then go from there. Drip varies greatly for run times, depending on the plant and depending on the type of drip you have. Okay, as I mentioned, start on the low end of the run times and increase only as necessary. And please keep in mind that for your turf grass, it's okay for it not to look like a golf course. It shouldn't. Most of us have Kentucky bluegrass or some other type of cool season grass that goes dormant in the summer. So if your yard looks like a golf course in the middle of summer, you're probably overwatering because it's not supposed to. So it goes dormant. It'll come back just fine. I'm not saying you shouldn't water it at all, but you don't have to go crazy. Okay, it'll come back. Grass is actually incredibly difficult to kill. All right, so here is an example program. So on program A, we have our turf grass. I'm just arbitrarily picking some days, Tuesdays and Fridays. Zones 1, 2, and 3, you can see their corresponding run times. They're different because I have different head types there. And then here are my 3 cycle start times. So I'm doing cycle and soak. On program B, I have my drip zone. I only need to water it in my example 1 day a week. So I'm picking Tuesday. That's my zone 4. I'm watering it for 60 minutes just for 1 cycle at 7:30. Remember, for drip, we don't have to do cycle and soak because it applies water so much more slowly that you don't really have the runoff issue. So it's fine to do 1 long cycle. All right. So I know I'm going faster now. It's because we're just about out of time. So one thing you can do to kind of upgrade your system is install a smart controller. So there are lots of different brands. We actually install Ratio smart controllers. So in a nutshell, smart controllers get weather data from local weather stations and adjust the schedule automatically, so you don't have to do it based on the weather. They're also handy because they are controlled via an app on your phone, and they're highly customizable. Okay. Things to know, it's not things that are bad about them, but just things to understand is that since they're talking to weather stations that aren't necessarily right next to you, sometimes the weather data they're using doesn't exactly match the weather at your house. So it may, if it's raining at the weather station and not raining at your house, it may still skip a watering or reduce your watering because it thinks it's raining there. So that can be an issue. Also, if you install this to replace your old clock, if you were already underwatering, the smart controller can actually increase your watering because it's reacting to the weather. And if you were doing less than you should have been doing, it won't know that. And so it might increase your watering. So you can prevent it from doing that by setting limits when you set it up, but it's just something to be aware of. And then also just know that if your sprinklers are in disrepair, a smart controller is not going to make a difference. So we talked about the 3 things that affect your sprinklers: your design, your maintenance, and your scheduling. If your design and your maintenance aren't good, your smart controller scheduling isn't really going to make a difference. So it's important to address what the actual issue is in that case. Rain sensors is another option. So rain sensors are compatible with most control clocks. And what they actually do is tell the clock to skip a watering when a certain rain threshold is met. Okay. And as I mentioned, they work with a lot of clocks. The calculated rainfall is specific to your property. Since the sensor is on your property, it knows when it's raining and when it doesn't. And good thing about these is they cannot increase your water use at all. They can only decrease it. So things to know about them is not all models of rain sensor are compatible with all clocks. So if you're looking at this, do your research, make sure your sensor that you want is compatible with your clock. Also, things to know, rain sensors do not adjust the amount of watering. So like the smart controller, if it rains a little bit, it'll still water, but will water less. Whereas a rain sensor, it's an on or off thing. So you set the threshold of water that you want it to hit before it trips. And if it doesn't hit that, it still lets the clock water. It only stops the clock from watering if it goes over that threshold. Another thing is make sure you have a good spot to put the sensor. So it needs to be out in the open, like at the top of a wooden fence, not under trees, because you want to make sure it's getting 100% of the rain that's falling on your property. And they do require occasional attention. like to clean them or to change out the battery. It's typically once a season or once every couple years, but it is just something to be aware of. All right, converting to drip. So when and why to do it? Basically, if you remove some of your turf and put in a garden, then you definitely want to convert those turf heads to drip. Or if you currently have a garden and it's being watered by those turf heads, because drip, again, is much more efficient for watering plants than your spray heads and your rotors that are intended for grass. And then how do you do it? So there are several kits available, or you can buy the individual parts. But basically what you do is you take one of those existing heads and you transform it and into your kind of drip hub, and then you cap the other heads in that zone, so that then you can still use that zone on your sprinkler system with your control clock like you did before. You'll just want to reprogram it, obviously, to then cater to the drip system. All right, so key takeaways. Your sprinkler system is only as strong as its weakest link. So again, those three components are your design, your maintenance, and your scheduling. So again, design is tough to change, but your maintenance and your scheduling are something that everybody can do, or at least do a lot of. Please regularly inspect your system, certainly right when you turn it on for the season, and then at least once a month throughout the irrigation season. Do those adjustments and repairs in a timely manner. Also, again, one hydro zone per sprinkler zone to make sure we're watering appropriately. Also, use the correct head types, head and nozzle types for each zone. Please use cycle and soak, those multiple cycles for all your turf zones. Adjust the watering schedule throughout the season, so more days per week, fewer days per week, things like that. And remember, it's okay for your lawn to not look like a golf course. It's not supposed to. All right, so I believe that is it. I know we are at a few minutes over. I'm happy to hang out for a little bit if anybody else wants to. I do not expect you to. I know we went a little over on time, but I'm happy to take some questions if anybody has any.
Well, thanks for powering through that last part.
Sorry, I know that I got fast there at the end.
Yes. So I'll say in general, we did have a lot of questions relating to drip. One resource I would really, really recommend is Colorado State Extension. They do have a little section where it says ask an expert. They have master gardeners that might be able to answer some of your drip questions that are a little more specific to your yard or your situation. One though, Neka, that I saw was, could you clarify to use when to use a soaker or when to use a micro spray, since both are good for dense plants?
Yeah, a lot of it is personal preference. So I personally, if I had a really thick perennial garden, I probably wouldn't use soaker hose, number one, unless you put it in when the plants are young and small. That will be hard to do and snake it through there. Plus, it's a little harder to see. So I would probably personally use a soaker hose, like I said, for a shrub line. And I would probably use the micro sprays for the perennials, but that is, again, largely due to personal preference. One other thing I will say about soaker hoses I've experienced is, especially if you do a pretty long run, you can get some fairly uneven watering. So the end of the run won't put out as much water as the beginning of the run. So I find that micro sprays work a little bit better in that regard. But again, if you're just going for a short run on like a shrub line, a soaker hose would probably be fine.
And I'll add to that saying micro sprays, spray water on top. So if you have flowers or something that you don't want to get wet on their petals, probably don't use a micro spray. If you want the water delivered at the root zone, do more of like the hose.
Yep.
So again, it depends, but
it depends. Yep.
Those are some things.
Yeah, because some plants don't like to get water on their leaves and other plants are fine with it. So that's another thing to consider too. Yep.
And then can you remind everyone what a hydrozone is?
A hydrozone, excellent question. So a hydrozone is an area with a specific plant watering need. So your grass is a hydrozone. A perennial shrub is a different hydrozone, and a vegetable garden is a different hydrozone. So it's not so much a physical area, although in your yard it is. It's more a watering need requirement.
Perfect.
So like even among plants, like a cactus has different watering needs than an annual flower does. So those would be different hydrozones technically. But as far as your landscape goes, you're generally, you can, mentally draw a line around like your lawn, which is your grass, and then your vegetable garden, and then your perennial garden. Those are distinct hydrozones.
All right. And then again, just since we're kind of running over here, I do want to do a little plug for more where you can find more information on our website, resourcecentral.org/sprinklers/residential. There is a resources page where we did go over a lot about scheduling basics and the common problems and how to fix them. So if there's details you feel like you missed, the links will be there that you can review those a little later. And again, if you're interested in getting a sprinkler eval from us, you can check there to see if you're eligible for that. So then we can come in person and actually see your yard and help answer questions there.
Right.
All right. And then this one, I'm not sure, this one's a little specific. I'm not sure if you'll be able to answer this, but if someone's transitioning from grass to like a xeriscape, at what point would you kind of convert from like rotors or sprays to a drip system?
Immediately.
Okay. You just let your grass die.
Well, I guess it depends on when you say they're transitioning. So
Mhm.
I would, as soon as I plant the plants, I would transform to drip, or like that would be part of the process. So
The when you plant, basically.
basically when you plant, you want to, I would ideally you want to have the drip correspond to when the plants go in. So in regards to transitioning, I know that can mean different things for different people. So if you're doing physical turf removal, that's a very quick thing and your grass comes out immediately, and then I would immediately convert to drip. If you're doing like a sheet mulch type thing or something that's going to take several months before you're planting, you have more time then. Just turn the zone off so you're not watering under your sheet mulching. And then if later you want to, convert that once you put your plants in, that's fine too. But yeah, I would say your conversion to drip ideally corresponds to the plants going in.
Okay, perfect. And then we had a couple questions about risers for low heads,
Mhm.
kind of basically how you put them in, or if you have any, not that you have to go over the whole process, but
Yeah,
what's the basics of installing a riser?
right. So actually here, let me try to find, I'm going to click back through some slides here. So don't look, I don't want to make anybody sick. I'm going through these fast. So I'm trying to find that slide that kind of was that X-ray view of a head. So there we go. There we go. So one thing you can do is for your head as it's, let me do it here. For your head that's buried, again, you're still going to have to dig out a little bit of dirt around it so you can actually get the head out. So right here at the bottom of the head, this head just screws on righty-tighty, lefty-loosey to this fitting right here on the swing arm. And so if you can get a good hold of the shaft here of the head, you just unscrew it and the head will literally just pull out of the hole. Then what you can do is you can get a little extension or a riser that's threaded, and then you stick that down in the hole and you screw that onto the swing arm fitting. Now what you'll want to do, you can buy them and they're kind of in increments and you cut them off where you need to. So they're usually in like 3/4 inch or 1 inch increments. And they'll come in like a long stick, and then you'll need to kind of figure out, do I need an extra 2 inches? Do I need an extra 3 inches? And then you can cut that off before you stick it in the hole. And then you stick it in the hole, screw it on here to the swing arm, or conversely, probably easier, screw it into the bottom of your head first and then put the whole thing back in there. So you're basically just inserting an extra little piece in between the swing arm assembly and the head itself. And then pack dirt back in there.
Well, I think I answered most of the other questions in the chat. One that we might want to expand on in case other people have questions is if and when you need to install like a pressure regulator on your system.
Right. So that's a great question. So if you have high pressure or you suspect you have high pressure, some valves have kind of pressure regulation integrated into them, and you can adjust them at the valve. So but you would really have to look and see what you have. And then otherwise, I would look at it to see, is it a systemic issue? So sometimes there might be high pressure on the entire sprinkler system. And if that's the case, you might want to consider installing a pressure regulator kind of upstream of all of the valves. But if it just appears to be an issue with one zone, then you can consider maybe adjusting it at the valve if you can, or swapping out the valve for a pressure regulated valve, or installing some other type of pressure reducer on that zone itself. You also can get pressure regulated heads. But again, if it's an entire zone, I wouldn't go that way because I'd rather replace one valve or install one pressure regulator than change out like four to 10 heads. Yeah. Good question.
And I'll say, let's just do one more.
Yep.
And this one, I'll say, you might not know the answer to. It's kind of a drip related question, but when you have the spaghetti lines coming out of a main line, is there a limit to how many that you can put on there? My thought it was probably relates to the water pressure and how long that main line is.
Yeah.
But in general, probably not super limited, correct?
Yeah, you can put a lot. So it does depend on, how long of that main line you go, but you can have your main line be typically like a couple 100 feet. And so it also depends on the gallon per hour of the emitters that you have on there. So it's not so much the number of emitters itself, it's the gallons per hour that are pulling. So if you have a bunch of half-gallon per hour emitters, gosh, over a long line, you could probably have 100. I mean, it really just depends on the particular stuff you're using, but it's a lot. So I would definitely look at the specific equipment you're using. And yes, that is a note. So drip lines do need to be pressure regulated. So it's usually around 30 PSI. And so you actually install a pressure regulator specifically on those, because if you use too high a water pressure, it damages the drip and it can blow the emitters off. So you definitely want to do that. So
which we see all the time during our evaluations, by the
we
way,
do.
just nozzle, just
Yeah. But
Yeah,
typically you can run a lot of emitters and a lot of microsprays off of a main drip line.
all right. Perfect. All right, so I think, we'll end there, but again, please visit our website. Again, we'll have this posted on YouTube if you want to watch the recording again, and we are actually doing this presentation again on August 29th. So if you want to come again, or you want to refer people to us later, come again. We also have plenty of other seminars that are running through the end of August, so please visit our website if you're interested to sign up for any more. Thank you again to Northern Water for sponsoring, and to Neka for presenting, and for all of you for spending your Tuesday night with us. So thank you so much. Have a good night.
Everybody, thanks for hanging out.